Hi, and welcome to the How to Draw Lewis dot structure of covalent molecules. This is example 3. We're going to draw the Lewis dot structure of ICl4 minus. Alright, so just remember that when we're drawing Lewis dot structures, we want to go from the chemical formula, like ICl4 minus, to a structure that shows you how these atoms are connected, what type of bonds are they connected with single, double, or triple bonds, and where the lone pairs are in the molecule. All right, the first step says to count the total number of valence electrons from all the atoms. And there's one little note here when we're dealing with charges. Notice that we have a minus charge. If you have a minus charge, you need to add that when you have a minus charge. So in our example, we have iodine and chlorine. We have one iodine, and though that's in group 17, so the total number of valence electrons, it's going to be 7 from the iodine. Chlorine is also in group 17, so it also has 7 valence electrons, and we've got 4 of them, so that's going to be 4 times 7. Now typically this is where we would stop, but because we have a -1 charge, we need to add 1 to the total valence electrons. So I'll write this in red. So because we have a negative charge, we're going to add 1 to the valence electrons. So that's why I added that one here. Okay, so we could go ahead and do my math. This is 35 plus 1, which is 36. I have 36 valence electrons. All right, the next step is to make our skeletal structure. And then remember, the skeletal structure, you have one atom that goes in the center, and then all the other atoms attached to it. So an atom in the center, and then all the other atoms will be attached to it with single bonds. Now, the rule for picking out which atom goes in the center has to do with the one that's least electronegative goes in the center. So if you recall from Unit 3, the electronegativity decreases as you go down a group. And since iodine is below chlorine, it's going to be the least electronegative. So it's going to go in the center. Now, of course, you can also choose which atom goes in the center by using the trick that the atom that's written first usually goes in the center, or the one atom that there's only one of. There's only one iodine in this formula that will go in the center. Of course, those tricks don't always work, but they usually do. All right, so iodine goes in the center, and I'm going to attach to it the 4 chlorines. There are 4 chlorines here, so 4 Cl's go on. And that's my skeletal structure. All right, the next step says to arrange the remaining electrons so every atom has 8 electrons around it. Well, if we recall each bond, there are 4 bonds in this skeletal structure. Each bond has 2 electrons. So far I use 1, 2, 3, 4 bonds. That will be 2, 4, 6, 8 electrons. So I've used up 8 electrons. So what does that tell me? How many do I have remaining? I have 28 electrons. Now what I'm going to do is I'm going to figure out, well, how many do I need to give every atom an octet? And if I have just enough, I will have all single bonds. If I have some extra left over, I'll have what's called an expanded octet. I would add that to the central atom. And if I don't have enough, then I'll have to make multiple bonds. All right, so let's go ahead and figure this out. And what I'll do is I'll just use the green pen to put X's around to represent where the valence electrons that I need. Now let's start in the center here. Notice that iodine has 2, 4, 6, 8 electrons around it. Each bond has 2, so the iodine is actually good. It doesn't need anything else right now. But look at this chlorine. This chlorine only has 1 bond attached to it, so it only has 2 electrons so far. To get to 8, it needs 6 more. And since all the chlorines look the same, they all have a single bond attached to it, they all need 6 more. So given the fact that I have 4 chlorines, and each of them needs 6, that means I need a total of 24 electrons to give everything an octet. But wait a second, this time I actually have 28, I actually have extra, all right? So I have 4 more extra. So where are those extra gonna go? So in that case, when you have extra, those extra go on the central atom in what's called an expanded octet. Now you can only expand the octet, and expanded means more than 8, right? You can only have an atom with more than 8 around it if the atom is an element that's in period 3 or below. So these are the only ones that can have expanded octet. So only period 3 or below, so sort of like box that off here. And iodine is clearly in below period 3, so it can have an expanded octet. And the reason why that is because if we go back to electron configuration, the first shell, which will correspond to hydrogen and helium, can only fit 2 electrons because it only has the 1s orbital. The second shell can fit 8 electrons because it has the 2s and the 2p orbitals. The third shell can fit 18 technically because it has the 3s, the 3p, and the 3ds. Even though we don't start filling the 3ds up right away, they are there, they are available. So we can expand that octet into up to 18. All right, so in our case, for this iodine, it doesn't need to expand up to 18. We're just going to add the extra 4 on it. So I'm going to redraw this structure here. I got iodine, I got my chlorines attached to it. Each chlorine is going to be good with 6 electrons around it, or 3 lone pairs, and a bond. So all the chlorines will have an octet. They'll have 6 electrons from the lone pairs and 2 from a bond. And then for the iodine, those extra 4 electrons, I've got 4 more to put in, that they will go in as lone pairs on the central atom. Okay, and so this iodine has an expanded octet. So if I go to check the structure to see if everything has an octet, all the chlorines are good. They all have 8 electrons around it. And the iodine has at least 8, so it's good as well. And iodine can have an expanded octet because it's in period 3 or below. All right, the last bit about checking formal charges, we won't really get into that, but again, I'll link resources if you want to see how to calculate formal charges. So just to quickly recap, we follow the steps as normal. Total number of valence electrons is the first step. Since we had a negative charge, we had to add 1 to our total number of valence electrons. The next step is to make our skeletal structure. Iodine went in the center because it was the least electronegative, and we connected all the other atoms, chlorines, to it. Then when we went to complete our structure, we determined that we had 4 more electrons, or 2 pairs of electrons, and we placed those on the central atom, the iodine, and that gave the iodine an expanded octet. And all the chlorines have their octet as well. All right, that's it for this video. Have a quality day.